that. Our next presenter is Benno Overeinder from NLNetLabs. Welcome.
Thank you. Hi. So, thank you. Well, let's introduce myself already. So, Benno Overeinder and NLNetLabs. My presentation will be about OpenDNSSEC 2.0 and beyond. So, what are our plans? Should I put up? Oh, it's being taken care of. Excellent. Yeah, thank you. Oh. Oh, thanks. Oh, I made a lot of animated slides. They won't animate now. I will improvise. No problem. So it's kind of an open. It's a homecoming for OpenDNSSEC actually, because it all started, I guess, 8 years ago, 7 years ago. There are a number of people who are involved from the very beginning, and it started all here in Sweden, with a number of organizations from Holland, the Netherlands, and the UK. And it's good to be back here again and to tell about the next major version of OpenDNSSEC. Thank you. Good. So I'm going to tell something about open source software, and I want to try to sell you open source software. So I think I can get away with a short pitch about OpenNetLabs, or NLNetLabs, our not-for-profit foundation, actually a charity foundation, so we do good for the community. And we contribute in different ways. We develop open source software. We contribute to open standards. And, well, we try to come up with new solutions to existing problems, or identify problems and come up with some ideas to solve that. And we present it at different occasions, meetings like this, like Netnod meeting, or RIPE meetings, or at the ITF, for example. So altogether, our mission and goal is kind of bridge the gap between research and operational practice, and find what is needed to contribute, such that we have a safe and secure internet. It's a kind of our focus nowadays, and it's an important focus. So open source software, we develop primarily DNS software. So it's the authoritative name server NSD, the recursive resolver Unbound, used on many different places here. The provisioning, so how do you run your operations? How can that be helped? It's something like OpenDNSSEC. I will come to that. That's actually the major theme of this presentation. And we get a number of libraries for the applications to interact with DNS. Something like GetDNS, we put a lot of attention in the last 2 years. Or LDNS, a well-known tool for many DNS researchers and developers if they want to test or write tools to evaluate different aspects of the DNS infrastructure. Our community activities are, well, again, open standards, so that's mainly our work within the ITF. We attend working groups, we help writing up drafts, and hopefully they become, after 1, 2, 3, 4, 5 years, an RFC. We share our findings at presentation. I already managed that. And last but not least, we also contribute to discussions in policy and governance ICANN. Good, sound technical input is always important, also in these kind of policy and governance fora. Good, enough, and NLNetLabs. OpenDNSSEC. In context, so what are we talking about? So this should be a nice animated picture, but doesn't matter. So first of all, that's it. There was DNS in this world, and later on we had DNSSEC, but that doesn't exist in a vacuum. So to run your DNS infrastructure, you have your deployment and your operations. And with that, so how do you run your service? How do you provision your zone files? How do you manage your zone files, etc.? And finally, there are these DNSSEC aware applications. And I won't go into that later. I put up some slides in my presentation, but I will skip them because the presentation after my presentation will exactly go over that, so that buy you 5 minutes of extra coffee time. And finally, we have something like OpenDNSSEC, which touches in that corner, it touches upon how do you run your DNSSEC infrastructure and how it fits in the DNS infrastructure. So that's how OpenDNSSEC is positioned in the whole DNS ecosystem. Good. Who's in for some DNSSEC? Yay, always. So, a challenge here, I want to explain it, DNSSEC, in 1 or 2 slides, actually 2 slides. Just a refreshment, because there will be a lot of DNS and DNSSEC later. Actually, tomorrow, I see Roy over there. There will be Dane about in the presentation after. So, also an exercise for me to keep that short. So, DNSSEC in 1 slide. It's actually copied from, or credited by Jeff Houston. What is DNSSEC? So, every answer from your name server is signed. So, if you if you try to resolve a record, an A record, you get an answer, you get the A record, the answer, with a signature. And a validating resolver can check the signature if the data is not tampered with, it's authentic. And there's something like a trust anchor. And Roy Arendt will talk much more about that in many more detail. And the trust anchor is the key that is used to sign the zone, the root zone, sorry. And now, and that's important, it's in the green frame. What DNSSEC does, it creates a chain of overlapping signatures from the root to the signature of the answer, to make sure that the answer is not tampered with, and you can trust the result of the answer actually from the name server or the resolver. Good, that's important to understand. So how does it work in practice? Again, this is a little bit messy now, but you can follow the steps. So first, point 1, I will move to one of these slides. Does it, can I beam? No, it's no. Oh yeah, right. No. Oh, can you help me out, Liman? I'm messing up your all your work.
What are you trying to do?
I found it. My laser beam. There it is. Yeah. So back to this figure. So I receive an A record for NLNetLabs with a signature. So first I want to check. Well, is this signature that signed by the key, the key from the zone NLNetLabs. There. So the next thing I ask is, give me the DNS key from NLNetLabs.nl. So, and that record is signed with the same key, so it's self-signed. That's step 1. Step 2, it will ask .nl, the Apex, for the delegation signer record for NLNetLabs. So this is this record, the DS record. It's a fingerprint of this key, and it's signed with a different signature. It's the signature of .nl. So the next thing, I need the key of the .nl zone, and again, that's self-signed. To check if this is the correct key for the .nl, I go up to the root. Again, I query for the DS record, the delegation signer record, and it's signed by the root signature. So, and then we don't ask for the DNS key for the root. The root key has been preloaded by the resolver. And how that is done, etc., will be discussed tomorrow, so this is the teaser. And now we can construct this set of overlapping signatures to validate that all the keys being used in different zones are correct, and the answer is signed indeed by .nl, NLNetLabs.nl for the A record. Good. Any questions? No? Thanks. So DNSSEC deployment and provisioning. So now we go back to OpenDNSSEC. So what is OpenDNSSEC? OpenDNSSEC is, we call it a turnkey solution for DNSSEC. And our logo was this one button push. So you just push OpenDNSSEC button and everything rolls out and is fine. It's not that easy. There are many more details. But that's the goal, and that's how it's designed. And it's name server agnostic. So it's not a name server itself. It accepts all kind of input for the DNS, and it sends out, it outputs different kind of output, files, AXVR, IXVRs, and it can interact, it can feed these signed zones to bind NSD, NOT, or other name servers. Again, it automates the zone signing and management. So when does it need to be resigned, which keys, etc. The key rollover and management, which is also quite complex. When have the keys to be refreshed, etc. And in DNSSEC, you also have key signing keys and zone signing keys. I won't go into the details, but there's a delicate interaction here, which has been automatically managed by OpenDNSSEC. Of course, it's RFC compliant. It has to interact with many other pieces of hardware, software, and it has to be interoperable, of course, otherwise no use. Good, so that's OpenDNSSEC as a design, these are our design goals. What are the key features? So it's a bump in the wire, so you can put it between your, in your provisioning system, between your slave servers, for example, name servers, and the first part of your provisioning system. And if it doesn't need to sign anything, just unsigned zones transfer it through OpenDNSSEC and stay unsigned and are pushed to your name servers. Or if it needs to be resigned or key rollover, etc., it does its job. It's policy-driven configuration. It might not be your favorite configuration language, but we use something like XML here. So it does says, well, signatures every 2 hours, look if there has to be something to be resigned. This PT2H. It's might be a strange way to describe intervals, time intervals, but it's an ISO standard. And refresh P3 days, every period for 3 days. Look if some signatures are starting to expire, and make sure you start re-signing 3 days before that. Same for key algorithm, length and rollover. You can specify the length and the algorithm of your key. And from these policy configurations, OpenDNSSEC generates its actions. Actually, it makes sure that your keys stays fresh and are rolled, or your zones are resigned at appropriate times, etc. Currently, OpenDNSSEC can be fed with files, zone files, or in a more dynamic environment with other name servers, with IXVRs and AXVRs. I say there's support for hardware security modules, but actually it relies on hardware support, hardware security modules. It doesn't do the crypto itself, but all crypto goes via HSMs. Come to that later. And we have several high-profile deployments currently. So in Sweden, IIS is using it. .nl, SRDN is using it. SurfNet, it's a Dutch NRN, there's a research network. France, Canada, and many other smaller organizations, not necessarily TLDs, are using our OpenDNSSEC as a provisioning, DNSSEC provisioning system. Good, where are we now? This is the architecture. So it's always difficult to tell how things work in a just simple architecture overview. But here you can see that it's kind of the bump in the wire. So there's the input adapter that accepts the IXVRs, the AXVRs, or the files. it makes sure that it's one uniform format for the signer engine. The signer engine actually signs the zone data. It uses for the crypto the HSM here and puts out the signed zone data. And again, output adapters can make sure that it is in appropriate format for the rest of the pipeline. So this is really the bump in the wire architecture. Interesting here, and I want to talk about that a little bit later in more detail, is the enforcer. All the key signing policies are here. This is the XML file I just briefly touched upon. And this is kind of the architecture of OpenDNSSEC. Quite simple, but it does a complex task. Again, so here we rely on a hardware security module for all the crypto. And within the project, the OpenDNSSEC project, there was also another software product, Soft HSM, which is a complete software implementation of the PKCS 11. That's a tongue twister for me. API. And well, quite modestly, we say, well, it can be used to test your OpenDNSSEC implementation with a PKCS 11 interface. But in practice, we see that a lot of organizations are just using Soft HSM as their crypto. So they don't necessarily buy HSMs. Soft HSM version 1 relied on Botan. Soft HSM version 2, the current version, uses both, or can be used with Botan, can be linked, compiled with Botan, or with OpenSSL. And for some environments and Linux distributions, this is a prerequisite. So OpenSSL, because of all kind of FIPS compliancy rules. Alternatives are, of course, is running your OpenDNSSEC environment with a real HSM. And they can be priced between 50 and 50,000 US dollar or euros. It's expensive. They can be expensive, and the price depends on the FIPS level. So if you have the highest FIPS level 4, you pay prime prices. Alternative, you can use for something like the CrypTech board. It stands apart as real HSM. It's actually also real HSM, but I set it apart because it's open architecture, it's open hardware, open software, and it's a project run by the community. One of Leif Johansson, I'm not sure I haven't seen him yet, but he will show up. He's one of the team leaders of this project. So if he shows up, ask him about CrypTech board or ask me, I'll know a little bit about it. And we used it actually last summer, the CrypTech board. During a workshop the CrypTech group organized, we could play with the CrypTech Alpha 3 version 3 boards. I hooked it up on my OpenDNSSEC test setup, and I succeeded in running or signing my zones with the CrypTech HSM. It's really cool. It's still, of course, alpha version, so there has to be a lot of work to be done here in performance and functionality, but it really looks promising. For the URL to the project is cryptech.is. But what next? So this is where we are now. So a little bit of history of how doing time-wise. Okay, it's fine. Some history of OpenDNSSEC, and now it all started with Swedes, the Dutch, and the British, and Canada was also sponsoring us. So I put here .se, but it's currently IIS, of course, the Swedish TLD. SDN also has a new logo. SurfNet also. Actually, NLNetLabs, we also updated our logo recently, so I should. So what about Nominet? There's a I checked their website. It's still Nominet, but different font.
I'm not sure. I stopped working there a year ago.
Yeah.
Since I left, they have updated
Their logo. Yeah, it's. So I should talk with Jacob and Sarah. They should also update their logos for Kirai. So Kirai is Jacob Slieter was involved. at the very start. Synodon, Roy Arendts, at that time at NLNet, was involved from the start. So these are all partners which were involved in the start. In 2008 or 9, you were more, yeah. So that's, and so the first version was in 2012 released, and currently we are now at the long-term support version 1.4. Most of the people use these one in production. This summer we had a 2.0 release. We were very proud of. There was a lot of work under the, it's a Dutch expression, motor hood, under the motor cup. I don't know. With it under the hood. Thank you. It's so handy to have to have Roy here. It's not per se in functionality, but we really put a lot of work in robustness and flexibility. It's not seen directly, but buys us a lot of goodness, buys a lot of flexibility for the future to improve upon OpenDNSSEC. So the next planned release for 2.1 is end of this year, and then we have frequent updates of this release. The project transferred in July to NLNetLabs, so we are now mainly contributing code. We still get some patches and feedback from the community, but all the old partners are still sponsoring us. So they contribute in funding or in any other way. So IIS is still helping us in continuous developing OpenDNSSEC. NLNet also. ServNet is focusing on the soft HSM development, and they also have some funds over there. So that is still a good project sponsored and supported by different partners. Good. OpenDNSSEC 1.4 to 2.0, what are the big differences? It's under the hood. It's the enforcer. So OpenDNSSEC 1.4 was still kind of rigid. So if you started a rollover of your key, and even if your zone would go bogus, you had just go through the whole procedure and then start the next key rollover to make sure that the zones, etc., are, well, not bogus anymore, valid. So there was no emergency rollover. It was very difficult. With OpenDNSSEC 2.0, this is changed, so it's much more flexible. It's not procedural anymore, but it's much more goal-driven. So depending on the goals and the preconditions, it makes changes to the next stable, valid state in your OpenDNSSEC key rollover. So it's kind of data-driven from the 80s, maybe 90s. When I was a student, I learned about data-driven computing, and it's much more detail explained in a key, in a paper published at CETN in 2012. And we also have a presentation at IPG explain it in more detail. I don't have the time, and it's really detailed, so I won't go into here. So the key features, well, performance, obviously. Always good to have better performance of your infrastructure, especially with large zones. We're currently also we tested it, for example, also with the German top-level domain, .de, and it runs fine. So it scales well. Multiple key rollover mechanisms, so you can run, you can currently run, roll over different keys, and it takes care that everything goes fine in the right order. Algorithm rollover, which was not supported in 1.4 yet, important for the near future. Combined signing key, key. There's also some people have with, for example, with elliptic curve think, well, just one key is sufficient, and I don't need a zone key signing key and a zone signing key. Just use one key. And support for unsigned zone, real bump in the wire. It was before 2.0. It was not. You need to configure a little bit and work around that part. So 2.0, what can be expected in the near future? So end of this year, 2.1 will be a stabilization of the user experience, we call it. It's actually getting the command line interface in line with all the functionality with the new OpenDNSSEC 2.x implementation. Maybe some functionality. Elliptic curve, for example, is kind of low-hanging fruit now today. So we will include that also in OpenDNSSEC 2.1, but not many changes. For 2.2 and 2.3, we have more a vision. So I can sum up all the things we want to include. Please feel free and send an email to the OpenDNSSEC users mailing list if you want to have something included or kind of a request for functionality. But the way we see how OpenDNSSEC 2.x should go forward in a more architectural way is that it should be, well, I like this, the performance as a structural property, one of my colleagues told me. And I like that expression. It's something, keep things simple and make it, well, we use the word compartmentalization. Make some building blocks from which you can implement and realize the full OpenDNSSEC bump in the wire setup. But also, if you want to use it differently, if your operational practice is different from what OpenDNSSEC offers you today, you should be able to adapt it in a way that it fits well within your Chef, Ansible, or Puppet environment, for example. And it should be an integrated part of your DNS system. And that's an evolutionary track. It's not from 2.2 to 2.3 we will have this. We just see that as a kind of a focus, a point on the horizon where we want to work towards it. And maybe if OpenDNSSEC 3.0 will be there, we have this plan realized, and that will be a major achievement also for me and for our team. And hopefully also being very useful for the, okay, this is the old slide, for the community. So we call it the Masterdont master plan. So that's a little bit back to this, our future view, how OpenDNSSEC should develop. It should be kind of an OpenDNSSEC signer on steroids. So it's something which is central in your organization, or not central in your organization. It's kind of with all kind of APIs. With you can hook it up into your OpenSSL, or sorry, your MySQL, PostgreSQL databases, or any other way you provision your zone files or whatever. On the one hand, you have the interfaces for HSMs or other cryptos. You can output dynamic DNS updates, AXVRs, IXVRs, just zone files, etc., etc. So that's something this is our future view, how we want to develop our software. Kind of the Unix philosophy, small, flexible tools, good at one single task, and if you combine them in a smart, flexible way, you have a more complex functionality, stable and efficient. Good. Given time, I will wrap up. I'm sorry I didn't give you 5 minutes back of your coffee time. I will skip this though, the DNSSEC aware applications. The next talk will be about securing email with Dane. But there are many other applications that can have some profit. So it's not only DNSSEC to secure the DNS infrastructure, but you can also use it in your applications as a trust infrastructure, security infrastructure. Skip. Concluding, summary. So again, OpenDNSSEC evolves to a flexible solution. The user defines how it's run, and that's important because nowadays people have to a little bit work around some of the ideas we initially had about OpenDNSSEC, how it should be used. Operational differences are different over, operational practices are different over different organizations. And make it indeed like the Unix philosophy, performance as a structural property. Make simple, modular components that run fast and stable. We also give OpenDNSSEC trainings. Previously there were some, quite often, OpenDNSSEC trainings here in Stockholm also. I think mainly sponsored by IAS. There are different courses to be given from 1-day course to 3-day master classes. And recently, Johan Ieren from Netnod and a colleague of mine, he went to the LACNIC region for a full-day DNSSEC, OpenDNSSEC training. And that's important. That's also part of our mission as a foundation, reaching out to community, exchange ideas, etc., and disseminating this kind of technology. Good. Thank you for your attention, and probably room for 1 or 2 questions. It's up to you, Siri. Thank you.
Thank you for that. For those of you who were here last year, the speakers received a robot clock. This year we thought maybe a speaker for a speaker.
Excellent, thank
There
you.
go.
A robot speaker, thank you.
Thank you.
Thank you very much.